Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at trigonometric functions of any angle. In previous videos we've talked about trigonometric functions in terms of right triangles. Now we're going to look at angles that can be anywhere in your Cartesian coordinate system or your rectangular coordinate system. So to start with, I want to take any general angle theta, and we'll just keep it in quadrant 1 for now. Just as a review, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. X is positive in this half of the graph, so in quadrant 1 and 4. Y is positive in quadrants 1 and 2. And I just want to review that because that's going to be important when we get into our trig functions. So if we take a segment and rotate it counterclockwise from the positive x-axis, we create an angle theta. If we were to drop down a perpendicular line from the end point, we would form a right triangle. And the horizontal distance would be x, the vertical distance would be y. We call the hypotenuse the radius. So it's the radius of the circle that's formed if we rotate that line. So we're going to define our trig functions now in terms of x, y, and r instead of opposite, adjacent, and hypotenuse. Let's start with sine. We know that sine theta is defined as the side opposite to the hypotenuse. So the side opposite would be y, hypotenuse is r. Cosine theta, we've learned, is defined as the side adjacent to the hypotenuse, that ratio. So in terms of my coordinate system, the adjacent side would be x, and the hypotenuse is r. Tangent of theta is always defined as the ratio of the opposite side to the adjacent side. So in terms of my Cartesian coordinate system, that would be y over x. Then if we wanted to take a look at the reciprocal functions, it's just going to be the cosecant is the reciprocal of sine, so the reciprocal of this would be r over y. Secant is the reciprocal of cosine, so it would be r over x. And cotangent is the reciprocal of tangent, so it would be x over y. We're still using our definitions that we did before. We're just replacing the word opposite with y, we're replacing the word adjacent with x, and we're replacing hypotenuse with r. So when we take an angle in standard position, it means its initial side is the positive x-axis. Positive rotation is a counterclockwise direction. Our angle can be in any of the 4 quadrants. I want to talk about what the sine, S-I-G-N, is of each of the trig functions in the various quadrants. So in quadrant 1, sine depends on, r is always going to be positive, so the positive negative value of sine will depend on whether y is positive or negative. In quadrant 1, y is positive, so sine is positive. So wherever y is positive, sine will also be positive. We know y is positive in quadrant 2, so the sine of the function would be positive in quadrant 2. In quadrants 3 and 4, the y value is negative, so sine is negative in those 2 quadrants. When we look at the cosine function, r again is always positive, so cos being negative or positive is going to depend on whether x is positive or negative. In quadrant 1, x is positive, so cos is positive. X is also positive in quadrant 4, so cos is positive in quadrant 4. X is negative in quadrants 2 and 3, so cos is negative in those two quadrants. The tangent ratio depends on the value of x and y. So, if x and y are both positive, which they are in quadrant 1, tan will be positive. In quadrant 2, y is positive, x is negative. So a positive divided by a negative will be negative. In quadrant 3, x and y are negative. So a negative divided by a negative will be positive. So tangent of an angle in quadrant 3 will be positive. And in quadrant 4, y is negative, x is positive. So a negative divided by a positive is a negative. So one way that you can remember where these trig functions are positive and negative is this little acronym. I'm going to look at each quadrant and write the trig functions that are positive. So in quadrant 1, they're all positive, so A. In quadrant 2, the only thing that's positive is sine, so I'm going to put an S there. In quadrant 3, the only function that's positive is tangent. Quadrant 4, the only function that's positive is cos. Now, I've heard teachers talk about CAST as an acronym to remember this, but what I like better is, because our angles all start in quadrant 1, we're going to start in quadrant 1, and a rotation should be counterclockwise, so I'm going to go counterclockwise. ASTC, all students take calculus. So that might be a way to help you remember which trig functions are positive in what quadrants and which ones are negative. Just as a note, I want to indicate or point out that this angle here would be 90 degrees. This is 180. This is 270. This is 0 degrees, and it's also 360 degrees. So understand that if you have an angle between 270 and 360 degrees, you're dealing with an angle in quadrant 4. So you don't need to know this when you're just punching a trig function on your calculator, because your calculator will know whether to assign it a positive or negative value. But you're going to need to know this when you're finding the inverse of trig functions, because your calculator can only give you one answer, and you have to realize there's two possibilities. So I want to take a look at finding the inverse trig functions and finding both angles, not just the one your calculator gives you. So let's take a look. In the past, when you were given a question like sine of theta is equal to 0.4, we were working with right triangles, which means we were only working with angles less than 90 degrees, which were angles in quadrant 1. So when we got an answer on our calculator, we knew it was the correct one. However, you're now getting to questions where you might see something like this. It says find theta if theta is greater than or equal to 0 degrees, but less than 360 degrees. So when you see a question like that, understand they're asking you in the whole 360 degrees, what are the two possible answers? So we're going to start off the same way we did before. We can find the inverse sine of 0.4, and we get an answer of 23.6 degrees. That angle is in quadrant 1 because it's between 0 and 90. We know that sine of an angle will be positive in quadrant 1, but now we have to just figure out where else will a sine function be positive. According to our little chart, we know that sine is also positive in quadrant 2. So I might suggest that you write those two quadrants or even make a little drawing. So you know that the angle is 23.6 degrees. So what we want to do is find this angle in quadrant 2. The biggest thing to remember when you're finding the other angle is always use your horizontal axes as reference, never your vertical axes. So when you're finding the other angle, you're either adding or subtracting 180 degrees, or you're adding or subtracting 360 degrees. So never use 90, never use 270. I want to find the angle in quadrant 2. I know that the amount of rotation from the horizontal axis will be 23.6 degrees. So I'm just going to write angle 1 is 23.6, so that's one of my answers. To get the second angle, I'm going to take 180 degrees and I'm going to subtract 23.6, because that amount of rotation will be equivalent to my reference angle of 23.6. When I subtract, I get 156.4 degrees. So those are my two answers. And you can always check by finding the sine of this, which will be 0.4. Check this one. You'll also get the sine of 156.4 degrees to equal 0.4. If we had cos of theta equals 0.25, we know that one angle will be the inverse cos of 0.25. When we find that angle, we get 75.5 degrees. That angle is less than 90 degrees, so we know that's in quadrant 1. Where else is cos positive? According to our Cartesian coordinate system that we just talked about, cos is also positive in quadrant 4. So I'm looking for an angle in quadrant 4 that will have that same cos. So it might help to draw it. There's my angle of 75.5 degrees. That's quadrant 1. In quadrant 4, to get this angle here, again from the horizontal axis, it will be a rotation of 75.5. So it'll be 360 degrees minus 75.5 degrees. So theta 1, the first angle is 75.5 degrees. To get the second angle, I'm going to take 360 degrees and subtract a rotation of 75.5 degrees, and I get 284.5 degrees. So there's my two possibilities. Again, find the cos of this to check, find the cos of this to check. Let's take a look at a few more questions. Okay, our next question deals with the tangent function. It's positive. We know that tangent is positive in quadrants 1 and 3. To find our first angle, we're going to do inverse tan of 1.42, and we get an angle of 54.8 degrees. So that's the angle in quadrant 1. The other angle will be in quadrant 3. So if the rotation from the horizontal axis is 54.8 degrees, the angle in quadrant 3 will be that amount of rotation from 180 degrees. So angle 2 will be 180 degrees plus 54.8. So you're always going from the horizontal, so either from 360 or 180. There's your two answers. And you're done. Again, you can check. I'd like to do 4 more examples, but we've run out of room on this video, so let's do a continuation to another.